On behalf of the Wireless Broadband Alliance, we would like to say a warm hello to everyone and welcome to the Wireless Global Congress Summer Webinar Series. Your webinar is about to commence and all attendees will be in listen-only mode for the duration of the webinar. After each presentation, there will be a question and answer session. So if you have any questions you would like to raise, please enter them into the questions pane on your control panel, which is on the top right-hand side of your screen. I would now like to hand over to your host for this webinar, Mr. Randall Schwartz, Founder and Principal Consultant of Wireless 2020.
Yes, good morning, good afternoon, and good evening for wherever everyone is today. I hope all are well during these special times. So, of course, we all missed each other in a meeting in Barcelona, but this series of webinars that WBA has held have been a good substitute for that. This is the final webinar in the series, and all the others have been extremely interesting. So for those who have attended, I hope you found them to be very interesting and informative, and we'll do the best we can to make our session today equally as interesting and informative. Today we're going to talk about IoT and the enterprise and consumer, and you know, Wi-Fi, which is our focus subject today, is one of the really interesting technologies to develop and influence IoT. So we've got a great list of speakers today to follow up on that subject. First, we want to thank our webinar sponsors, for our charter sponsors, Cisco, and Intel and Boingo. We very much appreciate their support for the series, and for our diamond sponsors, thank you to them as well for supporting the series. And again, we can't be all together in person. I think as many of us has found, getting together on a go-to webinar or a Zoom call, that's the best we can do. So that's what we'll try to do this morning. So we've got a great set of speakers. Again, thank you to the WBA for the opportunity to play host this morning. And we have Johan Turve from Aptilo. We have Mohammed Raed from S-Dataway. We have Lakshmi Thanayankizi from General Motors. We have Baha from Sundagi from Intel, and then Tiago Rodriguez from the WBA is with us this morning as well. So really look forward to hearing from our speakers and talking about Wi-Fi and how people are applying Wi-Fi to some of the challenges around IoT. And you know, for my part, you know, IoT obviously one of the most critical development areas in the wireless in the wireless market. Tremendous opportunity to create new use cases, apply new technology. But for those of you who have met me before and have listened to me speak before, we're always focused not only on these new use cases, but really understanding the business issues around that as well. So my thoughts and my questions will always have a focus on that. So we'll see how our speakers do, and we'll always have an eye to that. But really looking forward to it. So with that, I'm going to turn it over to Johan. So Johan Turve, the Vice President of Marketing for Aptilo Networks, and he will talk about zero touch IoT connectivity. Okay, Johan, I hand the microphone to you.
Johan, you're on mute. Would you mind just coming off mute, please?
Johan has that look of he's working on it.
Not now. Thank you.
There we are.
I had a slight problem with my Mac here. I do apologize. Unmuting should be a very simple task, but apparently not.
The new problems of our new connected society.
Right. Yeah, so hello everybody. My name is Johan Terve and I'm the VP Marketing at Aptilo Networks. And I will talk about today how the manual onboarding of Wi-Fi devices that we have today has become a huge showstopper for a mass market of Wi-Fi IoT. And how Aptilo, in cooperation with Amazon AWS IoT Core, has taken steps to overcome this issue. And we really encourage the industry to follow suit. We call this the Zero Touch Wi-Fi IoT initiative. But before I dive into this, I would like to share a few words about my company, Aptilo. Aptilo Networks is the world's #1 provider of Wi-Fi service management solutions for large-scale Wi-Fi. We have 100+ carrier Wi-Fi deployments, which collectively serves thousands of businesses, customers, and more than 200 million end users daily. We deliver our solutions as software or as cloud services, and our customers can move between those two. And in the IoT side, we have really decided for a cloud-first strategy. So we have now our Aptilo Zero Touch Wi-Fi IoT connectivity service that can be available as a private service or private cloud service on AWS. And we also have a cloud service for mobile operators, the Aptilo Connectivity Control Service, that also runs on AWS, that allows mobile operators to innovate in the IoT era. But we must remember one thing when it comes to IoT, and that is there is a lot of interest around cellular IoT and a lot of hype around that. But the matter of fact is that the vast majority of all IoT devices out there are short range. There are 19.1 billion short range IoT devices estimated by 2025. And this is from the Ericsson Mobility Report in June this year. And they are all powered by short-range technologies like Wi-Fi, Bluetooth, Zigbee, and others. There is only 5.5 billion IoT devices that runs on cellular or LPWAN technologies. So that's kind of interesting perspective, because still we see some kind of strange use cases for cellular IoT connectivity. I mean, obviously that is for moving things, but still we see SIM cards in things like projectors or indoor billboards, coffee machine, what have you. And that is kind of strange, isn't it? It's almost like you use the street lamp as a bed lamp when in the night. And I mean, why that would be ridiculous, right? Because the indoor lighting is already there, and so is Wi-Fi. And with Wi-Fi 6, Wi-Fi have become a technology that is even more IoT and operator friendly, with low power consumption, UFDMA scheduling, so you cannot say that it's best effort anymore, and even more spectrum. So all in all, why is it that Wi-Fi is not used more for IoT and especially industrial IoT? I give you a couple of reasons here. Manual onboarding. that is a big showstopper. And it becomes even more cumbersome for devices that not have keyboards and screens. And then we have the second thing, and that is when people think about Wi-Fi, they think about open Wi-Fi networks that are not secure enough. So the perception is that it's not secure enough. And you don't want things like electronic billboards to be hacked, right? So what we really need is something that is just as secure and seamless as the cellular network. And security, check on that. We have our 802.1x with encrypted radio traffic. And I would say that is as secure as the mobile network. But the onboarding of devices remains manual and in the existing solutions today. And that is a big problem. So what kind of existing solutions do we have today? They all require, as I said, manual action at first connection. You have the Wi-Fi Alliance Easy Connect, for instance, with a QR code. You have the Wi-Fi protected setup, WPS, requires a push on the button, or you do setup with a Bluetooth radio to communicate with an app, and then you set up the Wi-Fi credentials that way. And that is kind of weird because you really, if the only reason to have Bluetooth is to onboard a Wi-Fi device, then you are in big trouble, I would say. So we came to a discussion with Amazon around this. I think it was when we discussed how to host our new services. And we came up with an idea because they had already certificates on the devices that they needed. And we came up with this idea to have a zero-touch solution based on that. And I would say it's a game changer for Wi-Fi based IoT, because let's face it, with manual onboarding and 19.1 billion devices, that will just not scale. And the solution on a high level looks like this. IoT devices are on AWS IoT Core, and to be identified there, they have already X509 certificates. They are needed to be identified by AWS IoT Core. And then we, in this case, you are in you could say hen and egg situation. You do have a good setup for identifying the device, but the device cannot really connect because it's not onboarded to the Wi-Fi yet. So with the Aptilo Zero Touch, we make this all secure and seamless. So what we really do is that we have a cloud service called Zero Touch Wi-Fi IoT that integrates with AWS IoT Core in this case. It could be other IoT platforms in the future, but we have started out with AWS. And we integrate with AWS IoT Core. And as the device switch on, it will automatically try to connect to the Zero Touch SSID or HOTSPOT 2.0 service. And I will come to how that is happening in a while. When it tries to connect, we take the certificates and we try to upload that from AWS IoT Core, and then we compare with the certificate that is in the device. And if it's a match, then we allow the Wi-Fi connection. So that means that we utilize the certificate that is already present in AWS IoT Core to be able to authenticate the device for EAP TLS. And when it comes to the device support for this, it's all standard based. So you don't need any software in the device at all. It's all based on standards. All the device manufacturer need to do is to get the device to try to connect to a Zero Touch SSID or a HOTSPOT 2.0 Zero Touch service. And then the network owner of the Wi-Fi network configure, and that is a 5-minute configuration only, you configure their Wi-Fi backend to authenticate with our service or somebody else's service for that matter. And we are cooperating to drive this really now. We are cooperating with leading Wi-Fi module vendors. And one of them is Espressive. And we recently did a press release about this. And now they have this built into their SDK. So that means that all of a sudden, all devices that builds on the ESP from Espressive will now automatically have support for the Zero Touch concept. And the Zero Touch is an initiative from AVS and Aptilo, as I said, but there are no patents. So we really encourage the industry to follow suit here. We really think that this is the only way that we can provide a mass market for IoT. And of course, we also can do some other things with analytics and advanced policies. We have an analytics dashboard where we can show different data. We have APIs towards IoT applications so that they can fetch analytics. And we can also do smart policy lookups from other sources to decide connectivity policies. And then finally, we can send SMSs and email notifications to the administrators. For instance, should we allow this device on or not? And with that, I will challenge our mascot, Dottie, to try to make a better job even than I did to explain this for you. And although the video was intended to be a little bit funny, the actual timings and real test cases here that you will see in the video is actually live from our lab, where we used a Wi-Fi-enabled light bulb to compare the onboarding using a traditional app with Bluetooth with Zero Touch. So with that, I would like to hand over so we can start the video, please.
Let's arrange a race between Aptilo Zero Touch and traditional onboarding. For the traditional onboarding, we use an app that communicates with the device through a Bluetooth connection. The onboarding process starts with powering up the device. Then we have to establish contact and add the device through Bluetooth. And finally, log in to Wi-Fi by provisioning login credentials through Bluetooth. For Zero Touch, you have to set up a Zero Touch SSID or HOTSPOT 2.0 service and point to our service for authentication. This is an easy one-time configuration that takes minutes. Now all IoT devices with Zero Touch support will just automatically fly onto the secure Wi-Fi network forever. The device is securely verified through the existing certificate and our integration with IoT platforms such as Amazon AWS IoT Core. I will now start a race so we can compare the two methods head-to-head. On your marks, ready, go! The app is contacting the device via Bluetooth, while Zero Touch is verifying the device through the certificate. Wow! The Zero Touch device is already securely connected to Wi-Fi. The traditional app has established contact and added the device through Bluetooth. Now it's time to log into Wi-Fi. First we have to enter the SSID name, in this case multi-touch. Then the security key. It is quite likely that you make a typo here, which will only add to the frustration and time. Now the device is configured through Bluetooth with these credentials and tries to connect to Wi-Fi. Finally connected to Wi-Fi. 58 seconds compared to 14 seconds for Zero Touch. But it's not the onboarding time that is of greatest importance. For most IoT devices, it is okay if it takes a few minutes. It is the automatic connection that provides the scalability needed to support an IoT mass market, something that Aptilo Zero Touch can offer. Just imagine a company with 1,000 devices. It would take them 2 man-days using the traditional manual onboarding with an app. What's worse, you have to do it all over again when you change the Wi-Fi security key. This can also jeopardize the good practice to periodically change the security key. With Aptilo Zero Touch, it is all automatic, so each user can onboard their own IoT devices to the secure Wi-Fi network. And changing security settings is not a problem. If you want to learn more about how Aptilo Zero Touch can bring smarter connectivity to your IoT devices, use this link to contact us. Thank you for your attention.
So that was Dottie explaining Zero Touch. And with that, I hope you all got in the concept as such. And I would like to open up for questions now.
Okay, excellent. Thank you, Johan. And one question that I was thinking of as we step through this, there's a lot of chipset providers out there that can support low-cost chipsets to develop Wi-Fi IoT devices. But is there anything they need to do in their software to be able to be able to support the Zero Touch concept?
Yes, what they need to do is to make, and I think that Mohammed will elaborate even more on this in the next session here, but what they basically need to do is to make sure that the device automatically tries to connect to the Zero Touch SSID or the HOTSPOT 2.0 service if they support HOTSPOT 2.0 at all. But most chipsets out there do support what you really need for secure eAPTLS, and it supports 802.1x basically, and that is the most important thing for being able to do this. And then obviously they need to automatically connect, as I said, to the right SSID, the Zero Touch SSID. And we didn't want to call it Aptilo Zero Touch SSID because we really see this as something that competitors of us will do. And we welcome that because we think it's an industrial initiative that is needed. And the main thing here is that the network owner knows where they want to connect their devices. And they know that they are on AWS. So they use our service to authenticate through AWS. Maybe we will have for Azure and Google going forward. I would expect that. And so by using the same SSID, everybody can use that SSID. And then there is intelligence in the Wi-Fi network to figure out where to authenticate and how to do that.
Okay, and I guess this is a good follow-up. This is a question that came from the audience. Can a private enterprise use the Aptilo onboarding process with their own certificates or without AWS? Can this be applied if somebody's using another cloud service? Mohammed's shaking his head. It might be a perfect leading.
Yes, technically they can, but of course it's if an enterprise come and say I have my own certificate database where I have my 50 devices and I want this, then we will probably not make sense from a commercial point of view. But if they have it on, let's say, Azure, sorry about this, AWS, we love you. We will obviously be able to do the same thing there.
Okay, excellent, excellent. Again, after each speaker, we'll have a couple of questions, and then when we come to the end, we'll have a Q&A for the whole panel. And so if there are more questions that you have for Johan, then we can come to that. And with that, and with all of our leading questions that we have asked, we'll come now to Mohammed Raid, from Project Manager from S-Dataway. And Mohammed, you can take it away.
Yep. Thank you, Randall.
Okay.
All right. So welcome to everybody. Thank you to Johan, actually, because we got this opportunity through Johan and Aptilo. So I want to give them a special thanks for that. Today we're going to talk about IoT and everyday consumer goods. What I want you to be able to take from this presentation today is a different perspective on your coffee break, and how normal and seemingly mundane objects in your house can have a lot bigger impact on you, and can have a smarter view of the world, let's say. I just want to start by introducing our company. So we're a small Swiss company of around 35 people. We work mainly with varying types of customers in hardware development and in IoT. Our goal is to be a one-stop shop for our customers who come in with an idea and then come out with an industrialized product. We can do small volumes, as well as accompany our customers in their journey to mass produce in Asia or in the European Union. A small panel of our customers. As you can see, there are a little bit household names that you may know: Nespresso, Nestle, or Breville, if you have somebody from Australia in the audience. And for us, IoT has been there for a while. Let's say we've been developing Wi-Fi capable devices since 2011. We started back then. There were no cloud services with AWS or other providers. So the biggest challenge there was to build our own custom-made services that were on-premise, so really hosted web APIs on the customer's servers. And I mean, for these devices, Wi-Fi provisioning has been a total or a big problem, because back then we were using Linux-based Wi-Fi routers. Actually, we're taking out the boards from it and putting it in consumer devices. So you have to use an AP mode or access point mode, where you have to connect from your PC to the device, configure it, and then come out, which is purely a technical thing to do, and that normal consumers don't take the time to do it, because it's too much. Then with a little bit more democratization of chips, we went into more BLE-based solutions, where the idea was to connect the object to the cloud via the smartphone. It also helped us to automatize some testing on the production line and have let's say a wireless link on the production line between the testing facility and the device that is being uncovered or tested. As you see, we did many things between watch winders, some ironing equipment, some equipment for homes, and a smart watch here for detection of toxic gases in petroleum, in the petroleum industry. And then recently we've started to get more and more democratized Wi-Fi and BLE modules that are more cost-effective than a Linux-based Wi-Fi router, let's say. And here it opened up another, let's say, another perspective to how to producing and scaling mass-produced consumer goods and connecting them to the Wi-Fi, because now there's a question of security. There's more testing and standards to be met, and we still had the same problem as before, which is how do you provision the Wi-Fi? How do you connect this object to Wi-Fi? So using a smartphone was much easier for people, but again, it's cumbersome. You have to take your BLE, you have to do BLE. Sometimes pairing doesn't work, etc., etc. Then we use the Apple MFI program, which allows you to do really I don't want to steal the let's say the slogan, but zero touch provisioning of the Wi-Fi, since you can share your password with the device, from your phone to the device. However, you're putting away half of the market who has Android phones. And with on-screen entry, which I don't have an example here, for on-screen entry, we will never get in consumer products where we need to be cost effective. We'll never get to the level of fluidity on a keyboard such as like smartphones. So it was always cumbersome for the user and not really friendly, let's say. We've identified through the years a lot of pain points about IoT-enabled products. One of them on the consumer side is that every time you buy a new IoT device from a new manufacturer, you need to download their app. So your phone is filled with apps that control light, your coffee machine, your washing machine, etc. And that might become cumbersome for people as well, and people start to be reluctant to download or to connect their device. Again, Wi-Fi provisioning, we've talked a lot about that. On another level, for businesses, basically, if I have an offering for smart lighting in a building, and I say I want to connect it to the Wi-Fi, and Johan actually explained that a lot better. It's a long process, takes a lot of time and resources. And if somebody changes the Wi-Fi password, then we're good to do it all over again. Another point that has opened up recently with IoT is the fact that the node itself, or the product that we're developing, becomes the weakest link in all of the connectivity chain. Servers are well protected. Amazon servers are unhackable for now. But an IoT node that is there in the house of somebody who has who has a little bit of knowledge can become quite dangerous for them and for maybe their neighbors, or for the corporate security in general. And then for a production line. On the production line level, this added to a lot of complexity and a lot of security concerns, because you need to be able to provision some credentials and some certificates into the device that are very sensitive, that you don't want them to leak out. And having, let's say, trusting your corporate security on a third-party OEM is not usually the best approach to security. So these are really big points that we've been identifying through the years around putting IoT in consumer devices. So with Aptilo Zero Touch, we did something quickly the other day by connecting an Espressif development board to a router. There are 3 steps to follow. Provision the device certificate, which is already available. It's already one of the steps that we do in the production of these devices. Then we add the EAP TLS, which is basically close to WPA2 Enterprise or if you've seen it before, it's connecting to a Wi-Fi network where you need to give a username and a password, and then making the device connect to a specific SSID. An hour later, this is development hours, not the time it takes to connect to Wi-Fi. The whole connection is established, it is reliable, it works every time, and you don't need to know the password of this router right there. You don't need to provision anything. You don't even need to touch the device in question. And then we went a little bit further because we needed some coffee, and I hope you're still seeing all of this. Because we needed some coffee, and so we connected one of our machines that is based on Espressif to the Aptilo Zero Touch. So now I'm just starting up the power. What happens right here is that you will see the Wi-Fi LED will start to blink. This is when there is the exchange of certificate between the IoT device itself and the router. I don't think you see it very well, but I can assure you we got here to blue. And since we're steady, the machine is connected, and through a simple web API, I can come in, press on the on-off button. Of course, there's a little bit of lag, and the machine starts up. We're preheating, we can see the status, we can do really something live, let's say. A coffee machine is one of the good examples of that. You wake up in the morning, you're checking Facebook, Instagram, etc. You start it up so that you don't have to preheat it, and then you press on a button, and then suddenly it makes a coffee for you. You don't have to worry about anything. You just open a web page, you have your own credentials, and your machine is ready to go and is there for you in the morning. That's a nice use that we found for the Aptilo router. That way we can make our coffees from the desk and then get back to business, let's say. One final thought we had as well is around the production line itself. We know that there's a lot of use cases for consumers with loyalty programs, with getting data and analyzing consumer behavior in the IoT world. But in the production line, in our point of view, seemed to be put aside a little bit, which is understandable. So we imagined a production line where a PCB comes in with the Wi-Fi module, and it comes with a factory certificate that is quite, let's say, generic. You put it in, that factory certificate allows the device to connect to the Aptilo router and then to the IoT core from AWS. And then through AWS or another cloud provider, you can rotate that certificate to get the final device certificate, meaning that at this point, the OEM has zero interference with your provisioning of credentials or certificates, making it a little bit more secure and having less reliance on the OEM themselves. And then I'm very proud of this animation. That PCB can travel through the production line, become a microwave oven or anything else. And all during that time, it is connected to the Aptilo router, and it's giving out monitoring, it's giving data logging, it's crucial information for the production line itself and for let's say the company selling these products to get more data about their supply, how much is coming out. They can track them, they can see a lot of parameters. This is one of the ideas that we can see where zero-touch Wi-Fi can help and can even boost the availability of IoT devices in the future. Hand it back to you, Randall.
Okay, great, Mohammed. Thank you so much. You know, a couple of questions. you know, that's that last example that you were showing, and I'm sure we'll talk more about it, of implementing Wi-Fi IoT. A lot of times, as people are focused on the cost of implementing an IoT solution like that, they're focused on the devices and looking at how many sensors we may have and how much data we're sending. But a lot of that, you know, the background of collecting and organizing the data, that's a big component of the cost. Can you just talk a little bit about that and sort of helping people to understand sort of the total cost involved of implementing a solution like that?
Yes, exactly. So let's talk on a product level. You have some up cost coming from the Wi-Fi device itself. That's something you have to pay for. It doesn't come out for free, let's say. And then let's say, depending on the risk appetite of our customer or of the company building this, you might have more and more security features that you would like to add. That you can add a secure chip, for example, to store your credentials. Some others go with maybe tamper-proof protections on the PCBs and on the devices. So that really adds to your cost. Again, that's on the device itself or on the BOM cost. Then you have the production line itself, where the process becomes longer, which means that your devices, you're going to have less volume each day. So devices will cost more on the production side. The OEMs will charge you a little more because they need to develop some software. They need to put in place a lot of things for that to happen. And behind that, in everyday life, you have all the development costs you had for your cloud platform, where you need to collect your data, analyze it, do all of the analytics behind that. And let's not forget that the data itself transiting, you're paying for that data and you're paying for connection time. So in the business case needs to take care of all of these factors and make sure that the data collected and the actionable data that is really being collected behind that can benefit the business and can bring more revenues, for example, can bring more loyalty of customers, etc., etc. So there's a lot of factors to take into consideration.
And we'll talk about that. And on the other side, we were talking about you know, consumers and you know, what could be the impact of connecting a consumer world to a consumer good to you know, to the IoT world. So you know, enterprises, they have big problems to solve. You know, us consumers have little problems to solve. Well, what can be the impact of connecting a consumer good, you know, consumer goods, you know, into the IoT world?
You mean on the consumer themselves?
Yeah, I think so. Yeah.
For the consumer themselves, it's a way to have a better, let's say, a better lifestyle or a more connected lifestyle, or to have even data about yourself. I mean, some people wear a Fitbit to know how well they slept. Some others would like to monitor their coffee consumption. Some others would like to learn how to iron a little better, which is one of the use cases we've had. So by collecting all of that data on the normal behavior, you get a new sense and a new perspective on what you were doing with a task that seemed mundane. Now has become a little bit more complex. You gain more, so you get more engaged into it. And I think that's a very strong point and powerful way to continue with IoT. We know it's the future, so we need, as consumers, to benefit from it as well, and not just give our data out for free.
And for me personally, you know, I mean, first of all, I find that really interesting. But you had mentioned that IoT can help you iron better. Is there any way that IoT can help me iron less? I think is really what.
hopefully one day. Let's have that conversation offline.
We'll take that
for you.
Okay.
Randall, Randall, can I just jump in with one small clarification, please?
Yeah, please go ahead, Johan.
Thank you, Mohammed, for an excellent job covering the device side of the ecosystem. During Mohammed's presentation, he mentioned the Aptilo router a few times. And that was a little bit unfortunate because there was a logo also on the Cisco AP that we had in live demonstration. And actually that is just an Aptilo logo that we have glued on to a Cisco AP for demo purposes. In fact, there is no router from us involved at all. What we have is a cloud service, and the Wi-Fi network owner need to then forward authentication request for Zero Touch up to us, and we do the rest. So it's an authentication service, nothing else. I just wanted to clarify that, so nobody thinks that it only works with Aptilo router or something like that. It works with any Wi-Fi network.
All right.
You're right, John. Thank you.
Excellent. Okay. Well, again, and each speaker has done a great job of setting up the next speaker. So we'll continue on, and our next speaker is going to be Lakshmi Thanayankizo from a wireless connectivity specialist from GM. So I think we'll hear about doing, and Lakshmi, how as far as pronouncing your name, did I reach the 80th percentile, I hope, or
Lakshmi, we can't hear you, sorry.
Are you unmuted?
Sorry. Yes, I was muted. You were very good with the first name. The last name was maybe 60%, but that's good enough, you know. People.
I'm happy with 60%. That's good. That's good.
Okay. Can you see what I'm sharing?
Yep, there we are.
Okay. Okay, so hello everyone. My name is Lakshmi. I'm from General Motors. I'm responsible for connectivity, which includes Wi-Fi. The title of my presentation is Automotive Wi-Fi Trends and Challenges. So what I'll talk about today would be how Wi-Fi gets used in vehicles and what are some of the challenges that we face as an industry. Okay, so when you think cars and Wi-Fi, it's not very obvious what cars do with Wi-Fi. So what I'll do is I'll walk you through what we call day in the life of a car, which is your typical drive and all the things that cars do over Wi-Fi. So when you leave your home in the morning, your car might connect to your home hotspot, and it might download some things that it requires for the drive. It might talk to your garage door opener over Wi-Fi and ask to close the garage. As you keep moving, and it kind of almost happens as you transition from home to the car, right? It's very important for us to ensure that the customer's experience transitions properly from home to car. So if I'm a driver and I'm walking into my car and I'm on a call, I want to make sure my call seamlessly transfers to my car. My kids might have their iPads, and they come into the car, they want that connectivity to continue. They want that experience to continue. In the back, we want to make sure that the connection hands over from your home hotspot to the car hotspot. Now, if you have a premium car, you have what we call rear seat entertainment, which is like a TV in the car. So if you're watching a TV in the home and then you come into the car, you want to make sure your experience again hands over. So that seamless transfer experience is very important as the car moves on. Now, again, the car keeps moving. You might be talking to cars next to each other. So there is vehicle-to-vehicle communication, and GM was the first OEM to introduce vehicle-to-vehicle communication with our Cadillac vehicles. The vehicle could also be talking to the infrastructure. So you could be talking to a signal light. The signal light tells you that the signal is going to change to red, so the vehicle can slow down. You keep moving again, and this is one of my favorite features. It's called Marketplace. GM has where you can actually order a pizza. So my car orders a pizza for me. It knows my preferences, so it orders the pizza I like, and I just have to drive and pick it up. I keep driving. Now I get to a gas station, right? So the car in the background tells the gas station what grade of gas my car needs, right? And that communication happens in the background. The payment happens in the background. I just have to get out and pay for it. Now, I've used gas station as an example, but you could think of any infrastructure. This could be a dealership. I'm going into the dealership. I pull into the service lane. All the information is passed between the vehicle and the dealership, and the dealer knows exactly why I'm coming and what I need. And that's a great experience. Now I come back. I come back to my home. My car talks to my garage door opener. It opens, and if you think about the last presentation, maybe my car can talk to my coffee machine, and the coffee machine can have my coffee ready by the time I get home. So this animation just shows just a subset of things that happen today with the cars we have. And when you look at how this is changing, so this chart I have, it shows how the number of the connectivity in vehicle has grown over the last couple of years, and you can see it's really significantly grown, right? From even in the last 4 years, you can see there's a growth of 200%. What this graph doesn't show is, in addition to connectivity, adding connectivity to vehicles, the other thing that has happened parallelly is the data demands have gone up, right? So the data demand of the customer who comes into the vehicle and the data demand of the vehicle itself has grown. So if you think of, the first time connectivity got into a vehicle was back in '98 when GM introduced OnStar. We also were first with introducing Wi-Fi hotspot in the vehicle back in 2016. But the amount of data these features required was very minimal. But today, with all the connected features we have, like over-the-air updates, Super Cruise, which is a automatic cruise feature, the data needs of the vehicle grow significantly. And we see that from one year to another year, there is about a 200 to 300% growth in the data demands of the vehicle. So what I wanted to get to was, Wi-Fi is already being used a lot in vehicles, and this is growing, right? So when we get to Wi-Fi and connected vehicle, if you think of the animation or the animation that we just walked through, a lot of Wi-Fi things happen in the vehicle, but all those things can be, put in 3 buckets. The first bucket is vehicle connecting to a hotspot. Now that could be your home hotspot that the vehicle connected to. It could be the dealership hotspot. It could be the gas station. And the main purpose here is the vehicle needs access to data. And just like a phone, vehicles want to use Wi-Fi as much as possible, right? Or it could be because, we want to have some kind of context-aware service like the Domino or the gas station, right? So that is the first bucket, the first vertical that exists in a vehicle. The second vertical that exists in a vehicle is the vehicle as a hotspot. So this is, where me and my kids and my husband, we bring in all our devices into the car, and we want the vehicle to be the source of internet. So vehicle is a hotspot that serves all the devices that come into the car. That's a second vertical. The third vertical we have, and this is something which not many people are familiar with, is vehicle containing Wi-Fi nodes. And what that means is, if you think of a vehicle, vehicle has a lot of what we call electronic control units or ECUs, which are like mini computers, and these computers are connected over wire. It's a lot of wire. If you think of a typical vehicle, it's 40 kilograms of wire, and that adds to its mass, right? And if you just lay out these wires, they're about 5 kilometers long. So when you have more wires and the vehicle is heavier, it's bad for fuel efficiency. So there's a huge incentive into removing some of these wires, and we've been able to do that slowly with some features. So vehicles have features like tire pressure monitoring system, which are vehicle features which have become wireless. But there are a lot of features which are still wired, and I think there is an industry challenge to make them go wireless. Now, the main thing is all these 3 networks will coexist in the car, and it's a huge challenge from an automaker perspective to make sure that these 3 things exist and they don't step onto each other. So when my car is connecting to a home hotspot, trying to download an OTA package, at the same time my kid might be watching a Netflix movie on his iPad. I could be on a call. At the same time, my TPMS might be doing something. So all these things have to coexist without impacting each other, and that's a big challenge from an automaker perspective. Okay, so now I want to kind of go one level deep into each of these verticals. So if you think of each of these verticals, they have at a very high level, right? We have vehicle connecting to hotspots. What I've listed below is what is important for that connection. What is the MVP for that connection? Then you have the second vertical, which is vehicle is a hotspot. What is MVP for that connection? And the third vertical, where vehicle containing hotspots, and what is MVP? So if we go to the first one, where a vehicle is trying to connect to a hotspot, when a vehicle is trying to connect to a hotspot, it's almost very similar to any device trying to connect to a hotspot. We want to have a fast connection. We want it to be seamless. We want it to be opportunistic, meaning we want to use Wi-Fi as much as possible. We want proper convergence, meaning, when Wi-Fi is not available, we want a very fast handover to cellular, so the applications don't even see the impact of handover. And of course, we want it to be very, very secure. Right now, when a vehicle is a hotspot, the MVP changes a bit, right? Our first goal is the frictionless handover. So if a customer is coming from home to car, we want to make sure the experience hands over, right? The call hands over, the Netflix hands over, everything hands over. High efficiency, and this is very important, right? You would think like, why do we need a high efficiency network? People typically carry around 2 to 3 devices with them these days. And if you think of like a 3-seater vehicle, that's about 15 to 20 devices in a car, which is about 15 feet long. So it's very important, as their data needs go up, we have a very high efficiency network going on in the car, and we can continue meeting their data needs. Now, security is important for everything. The next thing important for vehicle as a hotspot is backward forward compatible. And what that means is we want to continue supporting any kind of device the customer brings into the car. It could be a phone 3 years old. It could be, the latest phone. It could be a wearable, but whatever it is, we want to be compatible with whatever device the customer brings into the car. And the third vertical is vehicle containing hotspots. So what's important for that vertical, right? So this is where you have all these mini computers in the car connected over wires. So these are features, safety features, usually ASIL rated, which have very, very stringent QoS requirements, right? So they are going over wires right now. So if we want to transition them to wireless, the most important thing is you have to meet, you need Wi-Fi to meet a quality which is comparable to a wired connection, right? So wired QoS, redundancy, safety, and coexistence. Because when you add a lot of these wireless nodes, you really have to make sure that they don't step onto each other. So what are some of the challenges we have as an automaker to meet these MVP? So let's look at the first vertical, right? So vehicle connects to hotspot. Your car is connecting to your home hotspot. Your car is connecting to your dealership hotspot, right? So as an OEM, we want to maximize opportunities for Wi-Fi connectivity, just like anybody, right? We want to use Wi-Fi as much as possible to meet the growing data needs. But we have some challenges. The first challenge is, and it's very obvious, the vehicle moves and is trying to connect to a hotspot that's static. Wi-Fi as a technology is really not meant for mobility. So if you think of your home, you're sitting or walking slowly and connecting to your home hotspot. You're never running 40 miles per hour trying to connect to your hotspot. So that's challenging for vehicles. The second one is the limited availability of hotspots. And what I mean by that is, like when I put a hotspot in my home, I make sure that there is good coverage in all the rooms of my house. I never think about the car in the garage or the car parked outside. So the Wi-Fi connectivity a vehicle, and this is very similar, not just a home, right? Even if it's a Starbucks or a McDonald's, the focus is always for providing connectivity to people inside the building and not the car outside the building. So whatever connectivity we get is really not per design, but by chance. And that makes meeting all these KPIs I have in there very challenging. So if you think of a fast connection and seamless, right? If a vehicle is moving at 40 miles per hour, it typically gets about 10 seconds of connection. We don't want to spend like 2 out of the 10 seconds trying to connect, right? And then the opportunistic and convergence, as much as we want to use Wi-Fi as much as possible when you're a moving vehicle, so there'll be a lot of handovers between Wi-Fi and cellular. So we want to make sure that there is a very good convergence where the handover between Wi-Fi and cellular is so good that it's the customer doesn't see that the application has handed over. And we feel that as an industry, the convergence and the fast connection and everything, the standards do not really account for mobility today. We are definitely exploring technologies like Passpoint, and I think open roaming is a very good initiative. We're exploring things like that to see how it can help us. But I think there are still some challenges left that we would have to address as a community. So now Next, when we go to the next vertical, which is vehicle as a hotspot, right? So when a vehicle is a hotspot, it's really, the expectation is that whatever performance I'm getting at my home, I want the same performance in my home, in my car, right? Whatever throughput I'm getting in my home, whatever quality I'm getting in my home for my applications, I want the same thing in my car. Now, why is this challenging for a car? There are two reasons. The first reason is dynamic outdoor environment challenges. And what that means is, so when I leave my house in the morning, which I haven't done much recently because of the current situation, but usually when I leave my house in the morning, it's not a very congested Wi-Fi environment. I keep driving to office, and I go through an interstate, and there isn't much Wi-Fi hotspots there as well. But I drive through a downtown, and there are a lot of Wi-Fi hotspots. It's very, very congested. And then I get to my office, right? So I'm on a call during this time, and I, as a customer, I expect my call to have the same experience all through my ride. But our external environment has changed considerably, from my home to the interstate to the downtown. So it's a big challenge for the automaker to ensure that the experience that our customer gets is consistent, irrespective of what the outdoor environment is. So that's a big challenge. The second challenge we have, and it's actually a much bigger challenge for us, is fast changes in customer preferences and devices. And what this means is, so typically people buy a car and they keep the car for 10 years. But if you think of your phone, you change your phone every year, or some people change less than a year, right? So it's, when we design a car, it's very important for us to make sure that we design it understanding the technologies of the next 10 years, understanding the features that could actually come in the next 10 years. And what we have identified is that when we define new standards and technologies, we haven't really accounted for automotive as a market, and we haven't really accounted for automotive as a market, and that makes things more challenging. Right, so I think there is a need in standard development to ensure that when we define all these new standards, when we define interoperability practices, we really have to account for automotive as a segment, and the fact that these cars actually stay out there 10 years, 20 years, right? So that has to be accounted for. Now, the last vertical is the third one, which is vehicle containing hotspots. So what does this mean, right? So a vehicle has all these sensors, as I said, mini computers or electronic control units. And like I said, there's a huge incentive if we can make these wireless, right? But there's a huge challenge to make them wireless, because these are active safety applications. These are safety applications which have very stringent quality requirements. So we feel that Wi-Fi, and in general any wireless medium, doesn't have, at least today, the enablers to ensure the reliability and stringent safety requirements and coexistence that a safety application requires. So there is a challenge there, I think, for us as an industry to see how we can make wireless communication more reliable, so that all these ECUs in the vehicle in future can potentially leverage that. Okay, so now that I've talked about, what kind of Wi-Fi exists in the vehicle and what kind of challenges we have as an industry, I do want to mention, like the future trends. So definitely, as automakers, we look at all new technologies coming in, right? Positioning, Wi-Fi 6E, V2X, 5G, Passpoint, Wi-Fi Aware, Halo, V2I, Open Roaming, Wi-Fi 7, everything, and we always explore them. We just don't monitor. We also contribute to these standard bodies just to make sure that we can continue leveraging these features as they come in to enhance the safety of our customers and give them new experiences and new features, right? So going to and this is one of my very favorite slide. The picture you have on the left is from 30 years back. It shows it was a test done here in Detroit, and that's what connected vehicles looked like 30 years back. The picture you have on the right is a GM Cruise vehicle, and you can see there is no steering wheel. It's a driverless vehicle, and that's pretty exciting. Just seeing that picture is pretty exciting. So I feel that automotive industry is going through a huge transformation. Connectivity is a huge enabler for that transformation, and specifically Wi-Fi. But some of the challenges that I talk through are real challenges, and I think there is a need for the standards and ecosystem to address some of these to meet the needs of connectivity in future. I'm really excited about the automotive group that Wireless Broadband Alliance has formed, specifically looking to address some of the challenges in automotive industry. I'm really hoping a lot of these would actually get addressed in that forum. And that brings me to the end of my presentation. So if you guys have any questions, I would be very, very happy to take them now.
Great, Lakshmi, thank you so much. One of the things that I always think is interesting, and when we look at the car environment specifically, like you were presenting, there is Wi-Fi. There is probably a mobile connection in the car. Can you talk about it as you're kind of envisioning that, the role that Wi-Fi plays and the way that maybe the mobile connection, whether that's 5G or LTE or whatever it is, how the role for each of those and how those interact when you were talking about the car as a hotspot that anyone in the car can connect to Wi-Fi at the car, and then probably the connection from the car out might be the mobile connection. So how do you see those two technologies sort of interplaying in the car environment?
Okay, so yeah, thanks for the question, Mary. So I think both these technologies are extremely important for us, right? Both cellular and both Wi-Fi. And from our perspective, any feature we have, we make a decision on what technology makes sense for that feature, right? So cellular is something which we require because Wi-Fi is not available all the time, right? So the way we see it is, cellular is our technology, is our cellular data. Cellular is our data pipe for all our applications, right? So every application, cellular is a main pipe, and as Wi-Fi becomes available, we transition to that, right? And we try to increase opportunities of how much we can use it, but we don't see one replacing the another, right? We need cellular all the time because the vehicle is moving. Wi-Fi is not available all the time, and then when we get Wi-Fi, we try to leverage that as much as possible. Does that answer your question?
Great question. And as we move towards, we all read about connected cars and things, and so as we move towards that last picture, maybe that's not the last one, but as we move to the last picture you showed in that sort of totally connected car environment, how do you see the connectivity needs, from the vehicle? I guess out, I found it really interesting. You were talking about sort of the inter-car connectivity, which is really interesting. But how do you see the connectivity needs changing and evolving? Maybe that's over the next, 10, 15 years as we go to that model.
Sure, and this is kind of, I think a lot of this is vision, right? I mean, we are really hoping to get there. So in terms of connectivity, I think if you think of the car's connectivity needs, right? The car's connectivity need is growing a lot because we're adding a lot of connected features, over-the-air updates, I mean, we already have level 2 autonomous vehicles. So the data needs of the car will continuously grow, right? So the vehicle will have loads of data that it'll have to upload and download. So that's one segment. The other segment is the customer inside the car, right? When you think of autonomous vehicles and everything, we're actually transitioning from a driver-centric vehicle to a passenger-centric vehicle because there is no driver anymore. When you're in the car in an autonomous vehicle and the only thing you want to be doing is be entertained, right? So people are going to expect a home-like experience or a cinema-like experience in a car because they'll want to watch movies, they'll want to do whatever they want. So we'll see that data needs of the customer in the car growing. At the same time, we'll see the needs of the car itself growing because it'll have a lot of data to upload and download.
Great. Thank you very much. And again, we'll have an opportunity to come back and have questions for follow-up questions, either for any of the panelists or for all of the panelists, as we get to our final Wi-Fi section. So we'll come to our final speaker, and Bahre Sagdev, research scientist from Intel. And Baha, welcome as an Intel alumnus. I'll give you a special welcome.
Thank you so much. Let me share the presentation. Can you hear me well?
Coming up. There it is.
Can you hear me?
Yep, we can hear you.
Okay, perfect.
See the screen.
Thank you so much. Great. Thank you, Randall. Again, my name is Bahar Sadeghi, and I'm delighted to have an opportunity to talk to you about Wi-Fi in industrial IoT. We all hear a lot about IoT and 5G, but Wi-Fi is also there. And sometimes I feel like Wi-Fi is like the good child that does everything perfectly, but quietly, and is less talked about. So let's talk about Wi-Fi. But let's just start with IoT and in fact the Industry 4.0 transformation and its implications on wireless connections in industrial networks. Today's factory automation networks are purpose-built, hierarchical, and inflexible in the sense that they don't allow different components at different layers of the automation pyramid to communicate with one another. It also consists of set of proprietary industrial Ethernet-based interfaces that in order to have them connected and talk with each other, hardware bridging is required. Now with Industry 4.0 transformation, this current architecture of today is being replaced with an interoperable, scalable, and flexible architecture, which is basically an interconnect, a mesh network, where all the components can talk with one another. There is no hardware bridging required. What this network requires, however, is deterministic connectivity among all of the elements. And in some cases, guaranteed latency is required, which is something that can be provided with time-sensitive networking, TSN, as well as workload acceleration by the FPGAs. Intel has solutions for all the components from the I/O devices all the way to the cloud with the CPUs and FPGAs that we have, and provide end-to-end solution for Industry 4.0. So Industry 4.0 covers different market segments from manufacturing to energy to healthcare and transportation, and it's enjoying global growth. The wireless segment, which we care about, is expected to grow at the fastest rate at a CAGR of 26%. But let's focus on the manufacturing. In manufacturing, the number of wireless connections is expected to surpass the fixed wire connections by year 2024. And let's remember, Wi-Fi is in all of these, Wi-Fi connections and Wi-Fi networks are in all of the factories and industrial plants and businesses. However, the requirements that the automation and OT have are very different from the requirements that for IT applications and how we are used to, the applications that we are used to using Wi-Fi and wireless connections for. One of the main requirements is, in fact, reliability and 24-hour, availability around the clock in the factory. And we know that that is a challenge for, Wi-Fi or actually in a wireless connection, but Wi-Fi also in the harsh RF environment of a factory floor. WBA and Metis Aerospace have been the leaders in conducting trials with Wi-Fi 6 in this on the industrial setting, in fact, in the Metis Aerospace factory. And they have shown that Wi-Fi 6 succeeds where the previous generations of Wi-Fi failed in meeting the connectivity and network requirements of Metis Aerospace in their factory. Now, before I talk to you about what are the features of Wi-Fi 6 that make it a good solution for IoT, let's remember, as I mentioned at the beginning of the talk, when we talk about Industry 4.0 and wireless connections, we have a choice of technology. 5G and private network 5Gs or private 5G networks are going to be there, but so are Wi-Fi standalone networks and also converged Wi-Fi and 5G deployments. WBA work group on 5G convergence and convergence has been looking at the different deployment scenarios, and they have a white paper that I've published and specifically covers a factory converged Wi-Fi 5G network. Now, what are these features of Wi-Fi 6 that make it a good choice for IoT? So the first one is greater scalability. Wi-Fi 6 is capable of handling a large number of devices. It also benefits from improved environmental robustness, and that's what we saw with the Metis Aerospace trial, where we had the harsh RF environment, and the interference Wi-Fi 6 can handle itself quite well. It also, Wi-Fi 6 requires the state-of-the-art security with WPA3, and we talked about the the onboarding. There are solutions that can be used, like as Johan described, and I'll be talking a little bit later about that in the presentation also. Being the latest generation of Wi-Fi, it enjoys it has much faster and better performance. And specifically with features like target wake time, TWT, it also is capable of reducing the power consumption of the devices significantly. And being very important for IoT, of course, is the increased determinism and the lower latency. And the way that Wi-Fi 6 manages that is because of the big change that has happened with Wi-Fi 6, where the decision-making logic has moved to the AP. It's not the distributed model anymore, which is the case with all the Wi-Fi generations before. And because of that, we can have a fully scheduled Wi-Fi network. So the AP is in control of all of the uplink and downlink transmissions, which gives it the power to control the determinism and the latency that different devices experience. Now, all of these improvements are there with Wi-Fi 6. With Wi-Fi 6E, which is the deployment of that in 6 gigahertz spectrum, we have a large amount of fresh spectrum, let's call it. There are no legacy devices there. Hence, all of these performances will be even further improved. So with Wi-Fi 6 and Wi-Fi 6E, we have made a giant leap towards support of applications that have stringent requirements like industrial IoT. I'm not sure we're fully there to address the requirements that Lakshmi mentioned for the cars yet, to the interconnect, but hopefully, that will be the next hurdle. As we're not stopping there, Wi-Fi 7 is up next and coming, which is based on the 802.11be, which is a project that is under development in IEEE, and has the goals of setting, the maximum throughput to at least 30 gigabit per second, and also reducing the worst case latency and jitter. So with all of these key features for IoT that we have with Wi-Fi 6, Wi-Fi 6E, and we're going to have with Wi-Fi 7, Wi-Fi is able to address the requirements of majority of industrial applications in use cases that we previously never thought of Wi-Fi for example, with robotics, automated guided vehicles, remote HMI, and so on. So there are two topics that are considered always a challenge for wireless and Wi-Fi in industrial settings, and I would like to spend a little bit of time on them. The first one is support for the deterministic low latency and applications. A good example of that is what Lakshmi was presenting with interconnects within the car. So where is Wi-Fi today with meeting these requirements? Wi-Fi 6 can achieve single-digit millisecond latency. Of course, the worst case can be higher, especially in congested environment, or the car, for example, with multiple, when there's interference. Another aspect that is very important is that Wi-Fi does seamlessly integrate with industrial control loop solutions. Now, these solutions are Ethernet-based, 802.3 based, and Wi-Fi being 802.11 technology seamlessly integrates with them, which is critical because it provides a flexible integration of all of the control and coordination mechanisms that an industrial network has. regardless of the wide segments, wide components or wireless components, which is really actually important and empowering for satisfying the QoS requirements of different applications within the network. Now, yes, this is where Wi-Fi 6 is. As I mentioned before, with Wi-Fi 7, the latency will be even reduced further. But there are use cases that require very stringent requirements, like the safety application in the car, that they would require new schemes like channel access, scheduled channel access with 802.1 TSN functionality, which is something that needs to be defined. The second topic that I wanted to talk about is very well covered by Johan and Mohammed in the earlier talks, is about the pain of bringing up onboarding of devices that are headless devices, and as well as in large number, which is exactly the case with industrial applications. So I would like to highlight Intel secured device onboarding solution that is also a cloud service with which enables fast, secure, and scalable onboarding of devices. It integrates seamlessly with existing solutions. So in fact, Intel and Aptilo are investigating integration of the Zero Touch with Intel Istio for a full solution. It also works with any hardware from ARM MCUs to Intel Xeons. It works with the on-premise cloud in the industrial setting, as well as the internet, and it provides late binding, which is one aspect that I wanted to highlight. So Intel Istio delivers binding at the end of the supply chain. One of the issues with IoT devices and manufacturing of IoT devices is the fact that depending on which ecosystem they're going to be working with, there are different SKUs required to be manufactured. So let's think of a home environment depending on a thermostat as a device, depending on whether this is an Apple home or an Amazon home or a Google home, then the thermostat manufacturers have to have different SKUs for the device to work within this ecosystem and environment. Now with Intel Istio, the software and security customization of the device, IoT device, happens at the end of the supply chain. So that enables the manufacturers to just produce one SKU, and after it is delivered to the customer, depending on what ecosystem is going to be working with, at that time the customization of the software and security happens, which really with late binding, it enables having reduced cost and complexity in the supply chain, and basically a single device SKU for all the customers can be produced. Now that brings me to the end of the presentation and the summary. So we talked about how Wi-Fi 6 and 6E meet the requirements of majority of IoT applications today. With Wi-Fi 7, we'll have further enhancement of these features for IoT applications, including support of deterministic low latency. And Intel provides end-to-end solution for Industry 4.0, including high-performance industrial Wi-Fi and secure device onboarding for IoT devices. Thank you for your attention. I'll be happy to address questions if there are any. Thank you.
Great. Bahar, thank you. And no discussion about Wi-Fi 6 would be complete without looking forward to Wi-Fi 7. Sort of, is there a time frame for that, or should I not buy any of my Wi-Fi 6 devices? Wi-Fi 7's right around the corner, or?
So as much as we love our Wi-Fi, development, any project that happens in IEEE, it has a lifetime, time scale to be developed. The timeline currently is that by Q2 of 2021, the first complete draft of the standard is going to be available, developed, but then to ratify that and complete that and publish that, that's another like a few years, 2-3 years after, 2.5-3 years after that. But it doesn't mean that it's gonna be that late, because usually what happens after, when the first draft is complete and the standard specification is mature enough, then it's taken up by Wi-Fi Alliance, and the certification program starts. That's the case. I mean, even today, 11AX, which is the Wi-Fi 6, is not published by IEEE 8.11, but it's complete mature enough that we already have devices and certifications in the market for that.
Okay, and just so that you know, whenever you talk about industry standards meetings, you can sort of judge. You see that I've attended many industry meetings. Johan and Tiago have probably attended even more than me. That's why their hair is missing. I see Mohammed has probably, looks like he's started to attend a few of the meetings as well. So always be careful about that. The other question, I'll ask you the same question. We went with Lakshmi. We were talking about in the car environment, in the industrial environment. How do you see, whether it's 5G or some other technology, how do you see sort of the Wi-Fi and 5G in a big industrial environment? How do you see those interacting with each other?
So as I mentioned, 5G and private 5G networks are going to be there. It really depends on the use cases and the specific scenario and the needs of the factory, let's say, as an example, or the industry, for which one they're going to go with. There's a lot of momentum around 5G for industry, but there's, as I mentioned, Wi-Fi meets the requirements of a lot of industrial applications, and because of that, can be used for cases that deploying a 5G core might not be the right path for the industry. So you can have standalone Wi-Fi deployments in those scenarios. But also there are cases that for different reasons, either is depending on the applications or cost cutting or different reasons, you can have a convergence of Wi-Fi and 5G together. That was the figure that I showed, which is from the WBA's white paper on the RAN convergence. And in those scenarios, you can basically leverage the resources from both Wi-Fi and 5G for high reliability and the lowest latency and the highest quality performance that you can get. So in that scenario, you have the 5G core control all of the resources, both 5G and Wi-Fi, and it's basically transparent. It doesn't care whether they're running over the air is a Wi-Fi or a 5G solution. Really depends on the needs of the industry, but all of those are valid and reasonable solutions to go with.
Excellent. Well, thank you so much. And I am going to step through the final presentation, and thank you for, sorry, we have to get through all this. Should have advanced through the legal disclaimer. Thank you.
Yeah, sorry, I have to.
And I'm going to give a short presentation here. Again, and as I said at the beginning, one of the things that Wireless 2020 is most famous for, in addition to understanding the technology trends and market trends in the wireless industry, kind of what we're most famous for is building business cases. So when we look at something like IoT, we're always sort of focused on the business case, and absolutely, no shade on any of our presenters or presenters of what we see in most conferences, and absolutely no question that IoT is one of the most important development areas for the wireless industry. But one of the trends that we see, and I see this talking to people from all over the world as they're involved in IoT sub-projects, is that 70 to 80% of IoT projects never get past the proof of concept stage, which might be surprising. And again, this we see this almost in every market across the world. But the question is why? And at least from our perspective, that when we're looking at IoT, a lot of the discussion is around use cases and technologies, but there is very little focus on the business case and what makes sense financially. And so perhaps in some of these cases, one of the steps that's missing is that we need to have a comprehensive business case really to test the economic viability and of these IoT projects. And maybe if we did that beforehand, we might save ourselves some time and some effort and probably some money. So from our perspective, as we look at IoT and how we go about developing a business case and looking at a business case for IoT, number one is to sort of analyze and be able to define the specific deployment for each use case, look at the deployment scenarios and exactly what it is that we're going to be testing or modeling. Look at the technology options here. We've talked about Wi-Fi, but we've also talked about we've talked about mobile technologies or 5G and how that interacts. If you're looking at Bluetooth, if you're looking at low power WAN technologies, what's the right technology for these? And then to look at the business case assumptions. And then we build up the business case, we look at the costs and the deployment for operations, analyze the cost savings. I think Mohammed had mentioned, for any kind of application, it may be helping to deploy something that will enable new revenue. Or maybe if we're talking about asset tracking, we're talking about the cost savings from devices that aren't lost, or in industrial settings, it may be saving utilities, or it may be saving operational costs. And then put those into a business case and be able to validate the deployment characteristics. And if we can validate a positive business case to justify that, then we want, even if we can justify the economics, then even within that, we want to be able to optimize the economics and maybe, even make that deployment more economically profitable. So that's sort of the approach that we have. So the first thing that we look at is we look at use cases, and we've talked about many. When we look at, here might be a list of IoT use cases, and we can go through and talk about 2 or 3 dozen different kinds of use cases, and people coming up with use cases all the time. We try to break that down and look at 3 different three different categories, if you will. And one might be broadly called sensor networks, and that might be infrequent, periodic kinds of deployments. For example, if we're looking at an agricultural network, maybe 1 or 2 times a day, if you have a bunch of moisture sensors in the soil around a large farm or something like that. Maybe 2 or 3 times a day, or maybe 1 time a day, you're sending maybe 10 kilobytes of data, so that might be a sensor network. Asset tracking, you might be looking at more infrequent, more frequent, periodic information. There might be more capacity that we're looking at as we upload that. And then what we'll sort of broadly call operational networks, whether that's industrial networks or healthcare networks, or maybe in a public transport or a manufacturing setting. And that may be constant communication back and forth. It could be uplink and downlink. We may see a mix of the kinds of sensors and IoT devices that we have on the network, where there may be some low capacity sensors that are on the network, or maybe in an industrial environment connected to the same network, we may have high capacity deployments, like certain kinds of industrial controllers, or even autonomous vehicles driving around in a manufacturing case. So this idea of looking at the use cases and being able to categorize them will help them as we go to build business cases. And so just as an example for how we might look at building up these business cases and the kinds of parameters that we might include in our business case, I'm using our YROI IoT business case that's from Wireless 2020. And this, you want to be able to go in and sort of quickly analyze the use case that you're interested in, build an economic model, and see if it's making sense for you or not. So first, I talked about being able to select between these two and then be able to build up the scenario. So how many sensors do we have? How often is the communication? Is it a static solution, or over time, as you're looking at 10 years, will the network grow? Will the number of sensors that are on the network grow? So all of these things can be set up to be able to set up that use case and be able to understand the use case. The second is to look at the technology, and then for each of those technology for the use case, the way that you've set it up, be able to understand the impact on both the CapEx for setting up the network, obviously very important, and then the OpEx, the ongoing OpEx for being able to control that. So first, we can look at the technology choice, and we've talked about Wi-Fi here. We might look at NB-IoT or LTE-M or low power WAN like a LoRa network or 5G or Bluetooth. And some of the questions we've had looked at, how do those things interact? You might look at, is there a one-level architecture or a two-level network architecture where you might have, say, a set of sensors that are in a factory. Those may back up to a report. The sensor network may back up to a reporting network, which might be a wired connection that may go back to a home office that's monitoring maybe 30 or 40 different manufacturing plants or something like that. So you can have a reporting network and then a sensor network and then a reporting network. So can you build that kind of model? And then you may want to look at things like how do choices that you make in the technology selection, how does that impact the overall business case? And you might look at things like battery life. If you have a lot of sensors that are out there and you have your choice between a low cost sensor that only has a battery life of say 3 or 4 years and a higher cost sensor that may have a battery life of 7 or 8 years, how does that impact the business case? And here in the CapEx graph that we're looking at, out here, this additional CapEx is that the battery life for the sensors that we're using expire, and then we need to do a refresh cycle on that. If this were a 3 or 4 year but a lower cost, we might see some smaller CapEx here, but that might be repeated a couple of times over the cost. So being able to make these trade-offs, and analyze these trade-offs to optimize the solution, those become very important. And then the final is really being able to look at and quantify, the cost savings that you're getting from the deployment or the revenue that you're getting from the deployment, and then being able to look at it. So in our model, we're able to sort of turn these things on and off. And it's nice to say on one hand, gee, if we deploy this in our factories, we're really going to see a lot of operational savings there, versus saying that by implementing this network, we have $800,000 of operational costs, and if we can reduce that by 8%, that's going to bring us a monthly cost savings of X, Y, or Z. So all too often, this, really putting the numbers to the business case and being able to justify the CapEx for deploying the network and being able to operate the network, and that those are justified, and to get us to a point at the end where we can do an analysis and be able to understand if that makes sense or not. So being able to look at the business case is absolutely critical, and hopefully, we want to validate the economic viability and understand how to optimize the profit from for the IoT business case to make that project successful. And hopefully, we can stop, at least some of these IoT projects from reaching a dead end. So that is kind of my input, and I always like to put that spin that looking at the business case is really critical. And again, I think that this is a problem that a lot of people in the IoT space are recognizing, and we're trying to do our part to go and to support that. So that was my piece of the presentation, and with that, we'll go to any questions. Again, if you have a question, please you can type it in the chat box, and we'll take a look at that, and we'll ask the panelists. I'll start with a question for all of the panelists, and we've talked about a number of different things, and Wi-Fi is one of the technologies that can be applied, and maybe the question is this: for the applications that we talked about, or pick your favorite one, what other technology do you see that potentially could be competitive with Wi-Fi in an IoT application? And what would you see as an argument for Wi-Fi and maybe against that competitive technology for the application that we're talking about? Johan, I'll start with you. We'll go in the order of our speakers for this question.
Yeah, I think I mentioned in my presentation a few other technologies, right? So obviously for moving things, it makes sense with a cellular network, and even other long-range WAN technologies such as LoRa, etc. And they all have their business case or use case, of course. And then in the home turf of short range and Wi-Fi, obviously there are other technologies like Zigbee and Bluetooth. But I think the thing is, most of these technologies have their very specific use cases. So if you take Bluetooth, of course, it's perfect for things like remote controls to television, TV sets, etc. Wi-Fi is more for industrial and for more, let's say, applications and devices that really need a robust and secure connection to the internet. And we talk about industrial side. I don't think there will be much Zigbee or Bluetooth in there, for instance. So every technology has its significant use case, and Wi-Fi is all over the place. As you know, there is no indoor location anymore that don't have Wi-Fi. So right. Why not use it?
Right. Mohammed?
Yeah. So I mean, I would like to say construct on what Johan was saying. It's indeed Wi-Fi is really in the middle of all of IoT. It is the most popular one and the most well established technology in homes and in factories and in other places. in my point of view, there's maybe 3 big technologies that really can compete directly. As Johan said, Bluetooth, for the reason of short range and low power consumption. When you need something that doesn't consume a lot of power, that is sleeping all day long and then just waking up a couple of times, like a TV remote. And then even in the building industry, Wi-Fi BLE mesh is picking up and giving more opportunities to have more, let's say, smart lighting. There's also 5G. We know all the buzz and hype around it. Between 5G and Wi-Fi, it's a close call for me, because the biggest argument of 5G, in my opinion, was latency. Low latency would allow you to get new use cases and to even penetrate the medical domain, having automation in the medical, like in the operation room. With Wi-Fi 6 and 7, as we're seeing today, we might get there even before 5G does. So it's a close call. And then for LoRa or Sigfox or other kinds of these networks, I think they're very business specific, and they do have their advantages in, let's say, in remote areas. If you find yourself on an offshore oil drilling platform and you need to connect all your sensors, I think you're better off with your own LoRa installation than trying to put 60 Wi-Fi routers in there. So right. It really depends, and they all have good credentials, and they're going forward in the future. But yeah, Wi-Fi will, in my opinion, still remain, let's say, the centerpiece of all Wi-Fi.
Okay, and Lakshmi, the in the in-car implementation, you were talking about removing wires and connecting things by Wi-Fi. Bluetooth might be another technology that you could look at there. Is that part of the consideration in addition to Wi-Fi, or is that a point where you pick one or the other?
So definitely for in-vehicle wireless, right? So we already have features like TPMS, which goes over BLE. I think the reason BLE and Bluetooth or Zigbee-based technologies are preferred are because they consume much less power, right? And also, like I think with some of the reliability requirements, Wi-Fi has traditionally been best effort. But I feel that with the new things, Wi-Fi 8, some of the things Baha talked about, right? I think there is Wi-Fi 7. I think there are things to look forward to as Wi-Fi gets more mature and gets more suitable for time-sensitive and reliable applications. I think it'll be a reevaluation feature by feature in future.
Excellent. And Baha?
So, I mean, everyone covered all the technologies. I think what has been happening that each of them started from where it was the right use case for them, and that's where they were developed. LoRa, Bluetooth, Zigbee, Wi-Fi, of course. But what has been happening over the last few years is that as technologists, everyone is developing these technologies further to cover go to the domain of others. For example, Bluetooth now has Bluetooth mesh and the long range, and Wi-Fi has Wi-Fi Halo that is lower power and longer range to compete with LoRa and all. I have spent almost 20 years on Wi-Fi, the last 5 years with IoT, so I can argue against any of this for 3 days straight and convince you that Wi-Fi is the best. But to be fair, is that really they all have, they're technologies that are intriguing, and when you learn about them, they're really well built for what they're doing, like LoRa or Bluetooth or Zigbee and all of those. And really, it goes back to what everyone said. There's specific use cases that would benefit best from each of them. The truth is, as we are going with IoT, is that the wealth of connections that the world will have will require all of these technologies. There'll be so diverse connections and requirements that we'll end up really using a lot of them. But of course, I have to say Wi-Fi is the one that we all love and believe in. So I think the main thing is that it's everywhere, as everyone said, and the cost low cost and the ease of deployment and ubiquitousness of it is critical for all these IoT applications.
Excellent, excellent. So with that, I will close our panel. Thank you to WBA for the opportunity for us to speak, and I'll hand it over to Tiago Rodriguez, the CEO of the Wireless Broadband Alliance, to wrap us up. Tiago?
Thank you, Randall. It was a very interesting webinar. So I want to start by thank you, Bahar, Lakshmi, Johan, Mohamed, and of course you, Randall, and even my colleague Sarah for helping and setting up this webinar. I think everyone got a very interesting views into the future of IoT and how Wi-Fi can help somehow that future. And I hope that, Randall, in a few years from now, we'll not see 70 or 80% of the IoT case studies being somehow stopped, but we can change that those numbers, and we see much more IoT deployments, because I think, especially on the industrial, but even in the residential, the IoT it helps us to make more intelligent decisions, because we have more data, and that data can help us either on our enterprises, on our manufacturing companies, or even our houses, making some decisions that somehow make us either more comfortable or more competitive if we are talking about the company. Okay, I just want to take a few minutes just to wrap up this webinar series. So today's webinar is the end of our summer 2020 webinars. Throughout these 8 webinars, we had more than 40 speakers. We had more than 900 registrations. We had almost 2,000 attendees between all the webinars. We cover a very vast topics, a very vast number of topics like Wi-Fi 6, Wi-Fi 6E, even today Bahar talked about Wi-Fi 7, spectrum, smart transportation, residential Wi-Fi, enterprise Wi-Fi, today all the time on IoT, security, carrier Wi-Fi, open roaming, Passpoint, and many other topics. I want to give as well a big thank you to our sponsors. Without them, we could not have this webinar. So Boeing, Cisco, Intel as our charter sponsors, thank you. But as well our diamond sponsors, so Global Reach, Huawei, Cognitive Systems, Maxima Telecom, On Semiconductors, STL, and Y-Connect. So thank you for making this possible. If you enjoy this webinar, stay tuned. We are already starting working on the next webinar series. Will be in the fall, in October and beginning of November. So our next webinars will be on the 27th to 29th of October, and then on the 3rd and 5th of November. If you are interested in attending, speaking, or sponsor, please visit wirelessglobalcongress.com. Drop us a message, leave your ideas. We'll be more than happy to reply to you and take in consideration any requests or ideas that you may have. Hope you have found these webinars useful and valuable to your companies. I look forward to see you guys all soon. I hope that pretty soon COVID-19 will be something from the past and we can start traveling again and meet face to face again. But taking in consideration the situation today, I think the webinar series was an interesting way to make us everyone closer to each other and maintain our relationships and our contacts and continue to do some type of networking and exchange of ideas. So thank you everyone for attending. Stay tuned for our October webinar series. Stay safe. Bye-bye from WBA and looking forward to see you soon. Thank you, everyone.
Great. Thank you, Tiago.
Thank you.